We're going to look at applied problems today, which are basically word problems. You may like word problems, you may not, but word problems are, for the most part, how things come to us when we're dealing with life or math in the real world with life. They're not necessarily given to us with formulas. We need to go ahead and figure out, from the context of what's going on, what's the equation or formula that would help us for a particular problem. Well, as we go through here, these are kind of the hints that you want to use and follow for solving applied problems. You want to read and reread the problem until you have a basic understanding of it. Not necessarily so you know the answer or know how to do it all, but just so you have a basic understanding. You want to use your variable to represent what you're looking for, and that works about 95% of the time. If it's kind of a real life situation, draw a diagram or a picture to try to help you with it. You may want to try to organize your information in a chart. Typically, you can do one of these two, maybe even both, and then you should be able to write your equation, then solve the equation, check your work, and then make sure you're answering the question that was being asked. Here we have a couple that doesn't want to spend more than $70 for their dinner at a restaurant. We want to know what's the most they can pay for their meal and still have tax and tip covered in the $70. So we're trying to figure out what they want for their meal. So we're going to let our variable represent their meal. I often like to choose my variable to represent something in the context of our problem. Here we're looking at our meal, so I'm using M. Now, your total bill comes from three things: cost of the meal, the tax, and the tip. We know from up here that the total is $70. Now, our meal, we know, is just M, because that's what we're saying our meal is. We don't know actual price yet. Now, your tax, it says, is 6%. So your tax is just going to be your 6% written as a decimal, so move your decimal point over two places, multiplied by your meal. So this right here is your tax. Now, together, these are going to help us, because together they are representing your meal and tax. You'll notice up here it says your tip is 15% after the tax has been added to the price of the meal. Well, you know, 15% as a decimal is 0.15. Well, we need your tax added to the meal. Your tax added to the meal is what we have right here. So it really needs to be 15% of that. So all we have to do now on the right-hand side is eliminate the parentheses, combine our like terms, and continue to solve it. Then you want to make sure you answer it in the context of the question. In this case, we're dealing with dollars, so the price of our meal for the couple could be $57.42. You may want to pause while you read through this. Now, we're trying to find whether it can be financed. It's a yes or no situation. So letting your variable represent yes or no isn't going to really help you in the context of your situation, but there's really two things we don't know. We don't know how much we're going to put in bonds, and we don't know how much we're going to get from the insurance company. So you'd want your variable to represent one of those two. I'm going to choose my variable to represent what we're getting in bonds. Well, if we had 200 in bonds, and you know you're getting 800 million, and so we're going to just eliminate the million part and just look at the 800. You know what you would get from your insurance company then would have to be 600, which comes from your 800 minus your 200 you had here. If you had 450, you know you would have 350, but how do you get that 350? It's your 800 minus your 450. So if you have B for your bonds, how do you get your insurance company? Same pattern, just 800 minus what you had for your bonds. And so what we have for our insurance company is 800 minus B. Well, what we're looking at here is our finance interest plus our interest from our bonds plus our interest from the insurance company. Our total finance interest is made up of these two. We know our total finance interest is 42 million. Our bonds have an interest rate of 6%. So how much interest you're paying on your bonds is your interest rate as a decimal times what you're putting in there, which we know is B. You then need to add to that how much you're putting in for interest for the insurance company, which you know is 5% according to what it's saying up here, times your amount you're putting in, which is your 800 minus B. So now you just want to quickly go ahead and solve that. And you would get 200, which means you'd be putting 200 million in bonds, 600 million then from the insurance company. So does that fit the criteria of the question? And the answer is yes. Here we're dealing with a mixture problem. And once again, you may want to read through this before we continue on. Well, we have two solutions that we're adding together to give us our final amount. So we're going to make ourselves a t-chart. We're going to have the percent of the solution times the amount of our solution equals our pure amount. We're going to have the stuff we start with plus the stuff we add and our final solution. So everything in this row going across is what we're starting out with. What we're adding is in this row here going across. What we're ending up with is down here. We're starting out with a 10% solution, so I'm going to put that as a decimal. We're adding a 1% solution. 1% is 0.01, and we want to end up with a 2% solution. Well, we know for our final amount, we want to have 15 milliliters. So whenever you have 2 of the 3 boxes filled out, you can easily get the third box, in this case by following the operations at the top. First column times second column equals your right-hand column. So just multiply across and we get our right-hand column. Now we don't really know how much of the 10%, we don't know how much of the 1%. So I'm going to let my variable represent one of those. I'm going to let it represent the amount of the 10% solution. Once again, we now have 2 of the 3 boxes filled out here, so we can multiply across. Our 0.10 times our x gives us our 0.1x. Well, what are we going to put in here? Well, oops, I guess I forgot to change this from the last problem. Well, if we started out with 3 milliliters of the 10% solution, we would then have 12 over here for the 1% solution, because you take 15 minus 3. Or if you started out with 7 from the 10%, that would then leave you with 8 over here, because we got to end up with our 15. Well, how do you get that 8? It's 15 minus your 7. So if we started out with B, or in the context of this problem, it would be x, and you get 15 minus x for your 1%. So then 2 of the 3 boxes, you multiply across. Now your equation on these mixture problems are always going to be what you start with plus what you add equals your final amount. We started with, we added, and we ended up with for your final amount. And that always comes from the pure amount column. So when you solve that, we get this. So in other words, we're going to have 5/3 milliliters of the 10% and 40/3 from the 1% solution.